evaluate the following integral by interpreting it as an area, and we have the integral from -5 to 5 of the quantity 5 minus the absolute value of x dx. All right, so we've got to figure out what that graph is going to look like. Now, there are different ways of doing this. You could make a table of values if you do not have any idea what it's going to look like. And if that's the case, you should go ahead and do that. But we can also think about what the graph of y equals the absolute value of x looks like. And we can think about what sorts of transformations this function undergoes when we've got a subtraction and when we've got the 5 out front. So we know that if we have the y equals the absolute value of x, I'm just going to draw super basic sketches over here. Do you know what shape that is? It is a V shape with a vertex at the origin. That is the absolute value function. If we instead put a negative in front, that is going to flip things vertically across the x-axis. That's actually going to take all those positive values and make them negative. So it's going to be an upside down V. And then if we add 5 to that, which is effectively what's happening when we're putting a 5 out front, that shifts everything up 5 units. And so that upside down V is going to be shifted up 5 units. I'm going to draw a nicer version of that for us. So here are our axes. And we said that it was shifted up 5 units. So that means that the vertex ends up being shifted up 5 units. And so I'm just going to decide that this is 5, and it's going to go down like that. And it's a 45-degree angle, so that's also going to be 5. And then on the left side, it's going down, and we're going to have -5 there. And so this integral is the area underneath this graph and above the x-axis, which we can shade in pretty easily. It'll take me a moment. I could pause it while I do this, but I think it might be nice to give you a moment to think, or if you're drawing along, to give you a moment as well. I think most students don't always take that many notes with online classes, which is not always the best. Also, it's a little therapeutic shading this in. But there we go. That is our shape. And it is a triangle. And we can see the base of the triangle is going to be 10 units because it goes from -5 to 5. And the height is 5. We know the area of a triangle is 1/2 the base times height. So that's going to be 1/2 times the base, which is 10, times the height, which is 5. 1/2 times 10 is 5, and 5 times 5 is 25. So that means that the value of that integral is equal to 25, based off that area that we just calculated. So, fun.